Alrighty, hey guys. Wednesday's lesson should be uploaded. Hopefully by the time you guys are watching this, you've already seen it and hopefully understood it. I will be checking my emails to see if you guys have any questions. But let's move on for the time being. And of course, I am still filming this one Tuesday night, which is why if you guys send me an email Wednesday night, I won't receive it before you guys get this video. But anything you guys might potentially send all the way up until probably Saturday or Sunday, I can incorporate into Monday's lesson. I just don't want to leave it to the last minute to start the filming, just because I'm trying to figure out right now still how to balance this with the university stuff, so I'm trying to film a little bit ahead of time in case I get too caught up in my homework. So apologies if anything you guys send for me to fix doesn't happen until next Wednesday, but I'm going to do my best. So today we're going to talk about first order, which actually this is already easier than stuff you guys have seen, so don't panic. Linear differential equations. So the way my professor explained it to us and the way I'm going to explain it to you guys is the first order bit really is not something to be afraid of. It's talking about the order of the derivative. So like a first order dE, that's differential equation, dE's. So a first order dE only has up to the first derivative. A second order dE has a second derivative and maybe a first derivative. So like the stuff we talked about in yesterday's class was actually more complicated than a first order dE. So what I'm going to do right now is I'm going to explain what a first order dE is, or what it looks like, and this linear bit, also don't worry about it. The linear here is pretty much saying that you don't have a lot of complicated stuff going on with your function. And I know that sounds a little bit wishy-washy and kind of difficult to understand what exactly I'm trying to say, but let it suffice to say that it's not a term you should be afraid of. So without further ado, this is the form of a first order linear dE, and I've actually pulled out my notes for this to make sure I don't get it wrong. So p of x. So p here is representing like a function of x. We just don't want to use letters. I mean, I guess you could use f, but there's going to be more than one function of x, and you don't want to use y because we're dealing with y separately. So we've got p of x, so that's going to be some function of x. Could be like e to the x, could be like a polynomial, could be a trig thing, but the trig thing I believe might, no, trig stuff is also good. Ignore the last 10 seconds. So p of x is like some function of x, so it could be like sine of x, or it could be e to the x, or it could be a polynomial, like a quadratic, fully expanded, times y prime. Alright? Times y prime, or the derivative of y with respect to x. Alright, so that's p of x multiplied by y prime plus q of x, so this is a separate function of x, times y, is equal to, I don't know why they didn't keep going p, q, r, they decided not to, g of x. Alright? And so, alright, so this might get to be a little bit much, so actually it might, most of today's class might just be explaining some of this stuff. I'm going to try and skip over the derivations and stuff because it's really not important for the stuff we're covering right now. I just want you guys to get a taste of differential equations before you head off to more advanced schooling or more advanced math classes. So here's an example. Actually, no, I'll do the example later. And so a simplified way to write it, just to clarify before I move on to the simplified way, quote-unquote simplified way of writing it, is that in a first-order linear differential equation, as with any differential equation, we're trying to solve for y. All right, so we don't want just y prime, we don't want p or q or g or anything else. We want to solve for that y right there. All right, so the simplified version is usually it's advantageous if you can get the y prime bit all by itself. So in other words, we want to get rid of this p of x business going on over here because we want to see just y prime there, which means we've got to divide out this p of x. And so the easiest way to do it is to just divide p of x out of every term. All right, so if you divide out p of x from here, you do like that. Oh lordy. So if you do p of x and you divide it out, then this p of x will cancel with that p of x, right? And then over here you also divide by p of x, so pretty much you just divide every term by p of x, and then over here you also divide by p of x, all right? So these ones have canceled, and so what you're left with is you've got just the y prime, which is exactly what we wanted to see, plus, sorry if the light is getting on the screen, I'll try to not let it become an issue. Maybe, what if I turn this off? Is that any better? Maybe it's a bit better. I'll leave it like this for a few minutes, and then you guys let me know afterwards in the comments or in an email which one was better, and we'll do that for Monday. So y prime plus, we've got q of x over p of x. Yeah, actually no. This is the simplified way is to write it instead of with a big Q. Now we write it with a little q. Bear with me, I know this is a little bit confusing because I was taught this in like a university manner, and so I'm teaching it to you guys in a university manner because I never came across differential equations in high school, so I don't know how to teach it in a better way. So you have y prime plus little q of x times y is equal to, following the same pattern as over here, little g of x. And so pretty much we haven't actually changed anything. All that we're saying is, so that we don't have to write as much down, is we're saying that right here we're saying that q, little q of x is just representing big Q of x divided by p of x. All right? And similarly over here we're suggesting that little g of x is simply representing big G of x divided by big P of x. All right? And so our simplified form is this one right here. And so this is what we're going to try and work with. So I'll give you guys a few seconds to write that down, and then I'm going to give you the next bit. This is called the standard form of a first order linear DE. I'm going to write that down just in case I refer to it as that. This is standard form of a first order linear DE. Alright. Oh, that E is slanted, like the Dell logo. Alright, so alright, now it's gonna start to look a little bit confusing, a little bit quickly. If you guys want me to go over the derivations either in like an extra lesson that you can watch at home, because I can upload more than the classroom videos because you guys can watch them anytime as long as you have Wi-Fi. So if you guys like, I can upload a special video just doing the derivation, but I'm going to jump straight to the next bit. I hope you guys have copied that down. Pause it now if you don't. And we're going to move on to all the bits we need to solve for the standard form of a first order linear DE. So I'm going to leave the equation up for just another sec because we need to figure out what all exactly we need to know, right? And so we don't actually need to know too many things. We only need to know a couple things. So if you look at the equation here, we're looking for y, right? And because we don't know y, that means we also don't know y prime, because if we knew y prime, then we could just do an integral, which is an antiderivative, to come out with y, right? If we had the derivative and we took an antiderivative, then we'll get our original function. But that's not something we're able to do. So right now we don't know y prime, so we've got a question mark there. We don't know y, all right? And this is what we're trying to figure out, is this y right here. But we also don't know q, and we also don't know g, little q and little g. All right, so those are our 4 things we need to know. And I'm going to leave in the Greek symbol just so I don't accidentally say the wrong thing, because I've already switched out one thing from my notes just for the sake of consistency with you guys from last class. But I am going to throw in a Greek symbol here in a sec. So we need to figure out what q is, and we need to figure out what y we should know. Sorry, that's a mistake. We would know, looking at the DE, what q is and what g is. We need to find out what y is and what y prime is. So we know, we need to know what this is. We would know what q is, and we would know what g is. All right, so we would know this, and we would know this. So those are things we can use to help us find y and y prime. All right, so the first thing is going to be this funny looking symbol. It's like an M that's a little bit longer down one side, or like a U that's like held by a stick, and this is called mu. If you need it, if you need the name ever, mu. All right, so mu of x. So this is like a function of x. This is a little bit weird. Bear with me. This video is just at 12 minutes now, so I'm going to get through mu of x, and then we'll just talk about it. Mu of x, the derivation is not important, but then the answer kind of looks like it comes out of nowhere without any explanation. But mu of x is e, so Euler's number, to the exponent of the integral of q, little q of x, dx. All right? That's what mu of x is. It's e to the exponent of the integral of little q of x dx. That's all in the exponent, all right? So we'll do an example of it either in the next 15 minutes or in the next class. But this is mu of x. Make sure you write it down. Don't worry about understanding where it comes from right now, because it is a couple pages worth of derivations in my notes. If you have any questions, write them down right now before you start part 2, or write them down at the end of class or something, and we will continue from here in just a moment.